Hello dear friends, welcome in today's online session. Today we are going to study chapter number 7, Motion, Force and Work. In previous period, you have learnt about the displacement, distance, velocity and other things. What is meant by displacement? Displacement means the minimum distance transferred by a moving body in one direction from the original point to reach the final point is called displacement. And you know that displacement is a vector quantity. In displacement, both distance and direction are taken into account. Therefore, it is a vector quantity. Now observe the pictures. There is one book on table. At a point, when the force is applied on the book is moved from one place to another place at point B. There is a next picture. A person is pulling a table by applying force and it moves from A point to B point. Dear student, you know that when we apply the force on a particular objects, it moves from their place and we say that the work is done. We have learnt about the relationship between the displacement of a body resulting from the force applied to it and the work is done. We have also learnt about the work-energy relationship. Dear student, do you know about energy? The capacity to do work is called energy. Energy is a scalar quantity. There is no need of direction to express the physical quantity. And what about the units of the energy? The unit of energy is joule. In SI system and in CGS system, it is erg. Okay. Let's focus on the quantities which are vector quantities. In this lesson, we have learnt about displacement, force, velocity, acceleration. All these quantities are vector quantities. There is a need of direction and magnitude to express the physical quantity. And speed, distance, work, energy are scalar quantity. There is no need of direction to express the physical quantity. Only magnitude is enough. Let's observe the figure. In the figure alongside, a string attached to a wooden block on a table is passed over a pulley and tied to a weight. On applying sufficient weight, the block will be seen to move. Which force is being applied here? How can this force be increased? What will happen on applying more force? When can we say that the work is done by the applied force? If the block moves forward, we can say that it has been displaced. Due to the displacement, we say that the force has done some work. Can we measure this work? We know that work done depends on the force and the displacement. There is one formula to find out the work done. We can calculate the work by using this formula. Work is equal to force into displacement. You know that the work done by the force is equal to force applied to the body into displacement of the body that takes place in the direction of the force. By using the formula W is equal to F into S, we can find out the work done. In the SI system, the unit of work is joule, while the unit of force is Newton and the unit of displacement is meter. In CGS system, the unit of work is erg. When we can say that the work is done? When body displaces by applying force. That means it moves after applying the force. So we can say that the work is done. Suppose we apply force on the wall, but it do not move, then work done is 0. Okay. If a force of 1 Newton parallel to the surface of the table is applied to a wooden block on the table and the block is displaced by 1 meter, then it can be said that the force has done 1 joule of work. In this example, the displacement is in the direction of the force. Yes, student, I hope you understood well about force, motion, velocity, acceleration, the terms expressed in 2 sessions. Okay, if there is any doubt about the concepts, please write in comment box. I will answer it. Okay, now complete the homework given here. Meet you in next session. Till then, take care. Goodbye.